All right, so as Kathleen said, I am Kirk Haynes. I work for Engine Yard. I'm a programmer here, and I'm also the Ruby 186 maintainer. I've been doing Ruby since early 2002, doing it professionally for a living since early 2002. And before that, I did a lot with Perl, and then a smattering with Java and C, and various other things from the mid-90s on. And that's basically where I come from. Today we're going to be talking about Tokyo Cabinet. Tokyo Cabinet is at its core, it's just a library for managing a key value type of database. It's in the same lineage as various DBM products that have been around for years, but it takes a whack at trying to get past a lot of the limitations that have been around for years in a lot of those packages. It tries very hard to be very fast, and it does a lot of things to try and be efficient with the use of disk space so that you don't get databases that continue growing open-ended the way some of the other DBM implementations will. It is designed so that it works well with multi-threading. You can have more than one thread working on a database at the same time without conflicts. And it was also designed with 64-bit architectures in mind. I have on here that it's robust, that bad things don't result in a corrupt database usually. I was just told about an instance today, in fact, where someone had a Tokyo Cabinet database get corrupted when they were using async put, and they ran out of disk space. But for the most part, it's pretty hard to damage your database. And that's kind of the high level of Tokyo Cabinet, where it comes from. The author created it originally. It was used in a very popular Japanese social networking site. Tokyo Cabinet is part of a family of Tokyo products. The core of it, as I said, is Tokyo Cabinet, but then built on top of that, there is Tokyo Tyrant. Now, Tokyo Tyrant is a network interface to a Tokyo Cabinet database. And what this does is it lets you have a database that looks like it's accessible from multiple machines over the network, so it acts more like a database server, like you're used to with a relational database such as MySQL or Oracle or Postgres, what have you. There's also Tokyo Dystopia, which is a full-text indexing and searching system that's built on top of the Tokyo libraries. And I'm not going to go over Tokyo Dystopia in this. It's kind of out of the scope of what I want to cover, as is Tokyo Promenade, which is a CMS system by the same author that has also been built on top of the same data store technology. Now, the high points of Tokyo Cabinet. As I've said, it's fast and robust. It will do, the actual speed of inserts and lookups and that sort of thing, of course, depends upon your system's disk speed and that sort of thing. But up to a point, and it varies some with tuning and that sort of thing, it will do a crazy number of inserts or lookups in a short period of time. It's very fast. It offers, and this is one of the things that I think is neatest about it, is that it offers several different data storage options. The main one that most people are probably, the one that's most familiar would be the hash tables, because a hash table is what you think of when you think of a key value store, and it's just a standard hashing type of system, just like any other hash. It also offers B-tree tables, and the nice thing about a B-tree table is while your lookups are going to be slower than in a hash table, it allows the keys in the table to be ordered, and Tokyo Cabinet will permit a person to supply an ordering function to it, so you can control how it orders it, and that then lets you do things like query ranges of data instead of just single items out of the database. And also because of the way the B-tree tables are implemented at a low level, the disk space that a B-tree table takes up tends to be smaller than that of a hash table. There's support additionally for compression and things like that in the library if you really want to eke your space out to get, I think, a quarter of the hash table size, somewhere in that neighborhood if you really need a smaller table. It also offers fixed length arrays, and that's just what it says. It's a very restricted sort of data storage format. Your keys are just numeric, and your data is a fixed length, but that lets your stuff be queried very quickly. I mean, all of these options then in conjunction with Tokyo Tyrant and Tokyo Dystopia offer a wide range of capability for a developer to take advantage of. Now, the Tokyo Cabinet, Tokyo Tyrant, etc. are accessible via they're a C library, and then there's several bindings for them. They come available with bindings for Ruby, Java, Lua, and Perl. And there are third-party bindings then as well that build on top of that to provide a nicer API for these. In my presentation here, I'm going to focus just on the Ruby side of things, but it's easy to find the information off of the Tokyo Cabinet website for those other bindings as well. Now, one of the things about Tokyo Cabinet that I think is very compelling is that there's a table database that it offers, and a table database gives you the appearance of, it looks like a standard relational database type of table. It has fields and columns just like any other table, but it's a free-form schema. So in that sense, it looks a little bit like a document store like you get out of CouchDB or out of MongoDB. And it allows you to do very sophisticated queries then on the data that you insert into it. It's a very flexible way of accessing your data. And just going into some of the more technical high points of Tokyo Cabinet, one process can handle multiple databases. With older DBM type implementations, they were limited to one instance of that DBM process was only able to deal with one database at a time. The key and the data in Tokyo Cabinet are, for practical purposes, unbounded. You know, there are some physical limitations, of course, but the database system itself doesn't impose any significant arbitrary limits on the size of your key or your data. The database system, the storage system is designed so that it isn't sparse. If something's deleted out of it and there's an empty hole there, the empty hole doesn't just get left there. It will try to defragment its storage space as it runs to keep everything tight. The overall database size limit is absurdly large. I would be fascinated to see a database that big and see how it actually ran into Tokyo Cabinet, but the top end is absurdly large. And as I mentioned earlier, when you're using true multi-threading, such as when you're accessing it via the C API, it will deal with that multi-threading. You can have multiple threads all operating on the same database at the same time. Now, there are some caveats about using Tokyo Cabinet with really large numbers of records. You know, we're talking like 100 million records, things like that. There are some wrinkles that show up, and I'll try and talk about those a little bit more down a little ways when we get to talking about the tuning. All right, this slide is, I guess, kind of redundant. I was just listing the storage options that are available, but I've already gone over those. Now, diving into each one individually a little bit, the hash tables use standard hash semantics. It'll be the same as a hash table in any other implementation, which means that the keys have to be unique. Now in Tokyo Cabinet, the key and the data both must be strings. And then the API that is exposed is fairly basic. It permits insertion, lookup, deletion, and traversal of keys. The data is unordered. There's no guarantee that insertion order is going to match traversal order or anything of that nature. And the operations are generally very fast with a hash table. All right. With the B-tree storage option, keys can be duplicated, so you can have multiple keys that have the same content, or the key is the same, but they have different values associated with them. Again, just like in the hash table, the keys and the data must be strings. The records are stored in order. The keys are sorted as they're inserted into the table, and that sorting function is user definable, so that if you want to override the default way of ordering for your application's data, there is a way to do that. And it offers all of the same options in the API for accessing the data as the hash does, but it also permits lookup on a range of keys. Inserts are relatively fast, but lookups are slower than a hash because being a tree, it may take several steps down the tree to find the particular record that you need. However, as I mentioned earlier, it's much more space efficient than a hash database typically. So if your application requires you to store a whole lot of data, it may be beneficial to put it in a B-tree instead of in a hash database if the disk space is a concern for your application. Now, the fixed length arrays are to my mind, they're kind of a neat feature, but they're very, very restricted in what you can do with them. Because it is a fixed record length, your data has to be relatively consistent, and it is keyed by unique integers. So it's just an array. It's very, very fast. So if speed is of utmost concern and your data fits it, it's a great thing. But it's difficult to get your data to fit it in a lot of cases, I think. It uses mmap to reduce the file overhead. It maps the data to memory. So it's very fast. But then there are limitations to the maximum amount of data you can store in a fixed length array. Basically, it's limited to your virtual memory size. Now, talking about the Ruby world and what's available in the Ruby world for dealing with Tokyo Cabinet, the standard binding that comes with Tokyo Cabinet is it's a very thin wrapper over the C API, and consequently, it's relatively straightforward to use. It's pretty fast, but from a aesthetic perspective, it's perhaps not the prettiest bit of Ruby code that you'll ever see. And it offers three basic classes for data storage that just match to those three options for what you have backing your database. You have a hash database, a B-tree database, a fixed length database. And that URL that you see on the slide there is where you can go to read in detail about the binding. What I'm going to do is I'm going to go through some live code examples here showing you how this binding works and then how some of the other bindings work with some of the different table types and data storage types. And so bear with me for a moment here while I switch over to my shell, and I'll show you some real code here. Alrighty, hopefully you all are seeing my shell now. I have this running on a standard Engine Yard cloud slice for demoing all this stuff. So it's running out on AWS. Seems to work pretty well for these purposes. The first thing we'll look at is standard binding. And what I've done here is I took back in a previous life, I did a lot of work with web applications for mutual fund companies and that sort of thing. And so I did a lot of work where I would take financial data and load it into some sort of a data store that would then be accessed later on a website for showing the fund price changes and things of that nature. And so I went and I took a little piece of old code that I had for loading this data, and I converted it to be a Tokyo cabinet-based loader. And so these examples are based off of actual real code that is actually still running out in production on a server out there in the world somewhere. Okay, let's do it this way. Ignore that there. I'm going to show you what the data looks like first, just so you can kind of know where it's coming from. It's just a simple CSV file, and it's got a ticker symbol, a date, some price information, nothing special going on there. All right, so this again is the standard binding for Tokyo Cabinet for Ruby. And as you look at it here, you can see that it's got semantics that are pretty similar to file semantics as far as opening and manipulating a file. And it works just fine. It's not aesthetically particularly beautiful, but it works just fine. And as you can see, all we're doing is we are opening our database, and we open it to be a writer. With Tokyo Cabinet, there's two permission modes. You can open to be a reader or a writer. A reader can only read data, can't change data. A writer can read as well as write data. And we're also saying that if the database doesn't exist already, create it. And then we just walk through it with the standard CSV library, walk through, read the data. I do some manipulations on it to make sure that it's in a consistent format, and I insert it into a Ruby hash. Now, Tokyo Cabinet, the library here for Ruby, the Tokyo Cabinet library for Ruby, does not do any marshalling of your data, either to or from the data store, and it will throw an exception if you try to write something that is not a string. So you need to make sure that what you are sending is actually a string, which is why down here I have a marshal dump, just to make sure that what we're storing is a string so that it doesn't blow up. And this is basically a simple example of how you write into a hash. And if I run it, it ran with no errors. Woohoo! Now, let's see if we can pull some data back out of there. This is an example of how to access the data, and the beginning part of it is the same as before. I actually could have changed this line from OWriter to be OReader and gotten rid of the HDB OCreate permission there, and it would have worked just fine since all we're doing is querying the data. And then to actually access the data, we just use it just like any other hash in Ruby. There's a store, and we pass it the term that we're going to query on, and it'll look it up. And then I'm putting it out to YAML because it's easy to view this complex data that way. And let's just look up a ticker symbol, and there you go. There's your stock information for Google from yesterday. If you're a Google shareholder, that's what you were looking at yesterday. Now, the the library also lets you iterate over keys in a hash. And the iterator, this is a perfect example of the thin wrapper. The iteration for Tokyo Cabinet hashes works by initializing the iterator, and then you have to sit here and you have to loop through the iterator, getting successive keys until you run out. It works pretty fast, but it isn't really a very Ruby sort of API. And I'll just run that quickly so you can see that that does in fact work. There's all the data that we just loaded. All right. So now back to my slides here. There's many different, well, there's several different Ruby interfaces to Tokyo Cabinet. And one of the ones that I like is the Rufus Tokyo binding. There are several others. Another interesting one that if you, at the end of this presentation, you'll see a link to various key value store articles I've written. And I just wrote a little bit on this particular interface. There's one called Moneta that is a unified interface to a whole bunch of different key value stores. And it's worth taking a look at. I'm not going to cover it in the time that I have today, but it's worth taking a look at. I use Rufus Tokyo when I need to do anything with Tokyo Cabinet because it's cleaner than the standard one from my perspective. It's a little bit prettier. It's not as fast. It uses FFI to interface to the library. So, for raw speed, if you need raw speed, it's not quite as fast, but I prefer to have a nicer API that's a little bit easier on my brain than the raw speed in most cases. And so I will go and show you a sample of the same code as before that I did with Rufus Tokyo. Excuse me. I'm getting over a flu that I had a couple weeks ago, and it's still plaguing me a little bit. All right. So Rufus Tokyo. It's the initialization of the database is a little bit simpler, a little bit less file-like, and a little bit more, I'm just creating this object, please give it to me. The rest of it isn't, for simple data storage, isn't really that much different. One key thing to remember, though, about Rufus Tokyo is that while the standard Tokyo Cabinet binding, if it receives a data item that is not a string, it will throw an exception. Rufus Tokyo tries to protect you from that, so it calls a 2s on any of the data that it's given. So if you pass it something that isn't a string, it'll just 2s it and go on its merry way, which maybe that's what you want. Maybe you wanted to know that, oops, I didn't pass it a string, in which case you won't. So you need to make sure you know what you're pushing in, or when you go and query your data back, you might get a surprise. You have a big mush string instead of data that you can actually use. And this thing, it's the exact same data as before, and it'll run exactly like before. And if we look at the reader, it's very similar to the one before. The API is just a little cleaner. Very similar to the one before. That's what Ford was doing yesterday. And here's a key difference, though, in the APIs. When you're iterating over your keys, you actually have a real Ruby iterator. You can just call each, and you can get your keys and your values just like you would expect out of any other data type in Ruby. And there it is again. Now, one of the things that I mentioned earlier on is that Tokyo Cabinet has this notion of table databases. Now, table databases are, under the covers, they're built out of the other primitive types of data store that Tokyo Cabinet has. For instance, the indexes in a table database are made out of B trees. But what it does is it gives you the familiar table that most people are used to when they're dealing with databases. And it's a free-form schema, which means you can insert any columns that you want, and they'll just work, and you can query them later. So in that sense, it is a lot like MongoDB or CouchDB, a document store of that nature. You can use it much the same way. And the table database semantics permit a much richer way of querying your data. It allows you to do greater thans, less thans, all your typical sort of Boolean comparisons. You can combine terms together and when building a query. If you're going to be querying particular columns frequently, you can build indexes on them. So it gives you a rich set of functionalities that is very similar to other database products, but without being a relational SQL database. It is slower. When you add all of that functionality on top of it, you pay a price in throughput for queries and that sort of thing. But on the flip side, it's just so much, as a developer, it's so much nicer for me to use that I really like table databases when my use case allows for it. And I will switch over to my shell now. I just about started typing in it without showing you guys what I was doing, so one moment here. All right, so here we are, same set of functionality, but this time implemented with Tokyo tables. The insertion is not really significantly different. You're still creating a hash just like before. The difference is that it's getting inserted into the database. The driver is taking it and inserting each of those fields as columns into the table so that they're then individually queryable later. And so we'll load that data. And I'm going to flip this around here and do the list all first because it's a simpler example. Again, it's very similar to the last one. It's in fact identical to the last one. Semantically, that bit of the API is no different. And it works, works the same way. Now when you're talking about a reader, though, it allows you to do some more complex things. And what I've done here is I've created a really simple query engine that will allow me to build up some complex queries on the command line. And the main things to look at in here are this store query line. It allows me to build up a query. And so I've got a loop in here that'll go over my arguments on the command line and just add Boolean string comparison lines here to build up a complex query. And so if we want to do something simple again, we can just say, oops, there we go. Just do that, and that gives us what happened to Google. It was just a simple lookup. But if we can do something complicated, we can say, show me everything where ticker is less than or equal to 10. Oh, not ticker. That's not the one I wanted. Price. Sorry, confusing the fields in my head. There. So the only one of those three where price was less than 10 is Ford. And we can do something like show me everything where price is greater than 10. There you go. This is the nice thing about the Tokio tables, is that you can interact with your data in a more complex, more rich way than you can with the simple data store types, at a cost, of course. Now, the next nice thing about Tokio Cabinet is that it has other things built on top of it. And one of the key pieces of functionality is Tokio Tyrant. Tokio Tyrant is a network interface for a Tokio Cabinet database, and it just lets you interact with your database from afar, just like it were some other type of database server. And it still manages to maintain a reasonable amount of functionality, or not functionality, but speed. And I've got a Tokio Tyrant example too to show you. Let me flip Windows once again. All right. So Tokio as a server process, and there are a boatload of command line tuning options that you can give to this thing to be very specific about what it's doing and how it's doing it and where it's doing it. But at its simplest, it's just TT server, and then you give it the name of a database file, and the name determines what kind of file it is, whether it's a table or a hash store or a B tree. There's different suffixes for those. In this case, we're going to create a Tokio Tyrant table database again. So we start it up. I'll flip back to the other window here and show you this code. One of the nice things about working with Tokio Tyrant is that your code changes very, very little. The only real change is in this first line here, where you are creating your object that accesses your data store. You're creating a Tyrant table now, and you give it the location where your server is running at, and the rest of your code need not change at all. All that code there is identical to the previous table example code, and it'll just work. Just works. Just works. It's a very nice addition to the Tokio family of products that really makes Tokio Tyrant something nice to use. All right, tuning. Tuning is an interesting topic with Tokio Cabinet because there aren't really a whole lot of online resources that talk about it right now. And a lot of what you find out there you have to really kind of dig through and think really hard about in order to really get what it's saying. The biggest thing here at Engine Yard that we've found just from empirical testing, from problems that customers have had, is that when you're running your Tokio Cabinet, when you're running TT server, you're running your Tokio Cabinet server, you really need to make sure that you specify enough buckets, enough hash buckets for the data set that you've got. Without diving into it in too much depth in the time that we have remaining, the Tokio Cabinet maintains a list of hash buckets in memory, and those buckets are what it uses to track down the various data items. And if you have too few hash buckets, then your hash collision rate increases tremendously, and that results in a huge number of file accesses to find any piece of data. And so the general guideline that you can find online says that you need between 0.5 and 4 hash buckets per record, depending upon your data. What we've found is that aim high. You need 4 or sometimes even more than that, to really get good performance, especially if you have a huge number of records. If you don't have enough hash buckets, what you'll find is that it works all right for a while, but you'll hit a very sharp point somewhere in your data set where all of a sudden the I/O weight just shoots through the roof, and it's not gradual. Once you hit that point, it happens very quickly. Your I/O weight goes through the roof, your machine slows to a crawl, your throughput just drops like a rock, and it doesn't work very well. And if you run into that, take a look at how many buckets you have versus how many records you have. Odds are you don't have enough buckets. Now, Tokio does coalesce the unused slots in the database. So, for instance, if records are deleted out of the database, Tokio will try and put new things back into those unused slots or move things around in order to keep the database file itself from growing, and becoming a sparse file versus a dense file. I was talking with someone here today, just this morning as a matter of fact, and going back to the buckets thing, and he was telling me a story about a database that he was working on with 250 million records, I think he said, and running 1 billion buckets on that 250 million record database. He had a hash collision rate of about 4%, and may not seem like a lot, but when you're talking that many records, that still means that there are a fair number of lookups that have to bounce through a bunch of chains of file operations before it finds what it's looking for. And so this is, I guess, one of the caveats about Tokio Cabinet, is that when you're dealing with huge data sets, it is still a little rough. There's caveats. You really need to, if you're going to consider Tokio Cabinet for a large data set, you need to do some testing yourself, some benchmarking, and see if it'll actually work for your use case. If you have a really huge a really huge database, re-optimizing that database might take a very long time. Jeremy Heinegardner is working on a fast optimize that he said will be up at his GitHub repo at some point, that tries to go into the file itself and optimize it outside of Tokio Cabinet. And so keep an eye on that if you're dealing with huge data sets, because that might be very helpful. And the hashing algorithm, in Tokio Cabinet probably needs a little bit of love. It's got some rough edges which contribute to the hash collisions when there are lots of records. One thing that you might consider if you are doing lots and lots of inserts in your particular use case is compiling your own version of Tokio Cabinet. In tcdbh.c, there's a whole bunch of constants that define a bunch of things that don't have tuning knobs in the code. And a couple of things that are of particular interest are buffer sizes. Those are the constants that I put down there at the bottom of that slide to pay particular interest to. The first one is of the insert. It's a buffer for insert statements, and by default it's 32K. But if you're doing a whole bunch of inserts at a time, you might want to bump that thing up to a megabyte or a gigabyte, whatever fits your use case, and recompile, benchmark it, and see if it helps you out. And if you are using Tokio Cabinet with async puts, those other two buffer constants there, you might also want to play with. For really large data sets, manipulating those can give you a little bit better performance. So, summarize everything I've sort of zoomed through here. Read the docs if you're going to use Tokio Cabinet. The docs aren't the greatest, but so you kind of have to just sit down and grit your way through them. But there are a lot of different knobs you can manipulate to control all sorts of settings as far as how Tokio runs and how it optimizes your data. It is fast, it is stable, it is easy to use. There are a lot of people using it with really large data sets and having no problems with it at all. As you've seen, there's a lot of flexibility in your data stores. I really love the Tokio tables for a lot of cases. If you have really huge data sets, they're going to have some problems. But for a lot of cases, I love the flexibility that they give. And yeah, when in doubt, just try it out, benchmark it, see if it works. If it's pretty easy to check it out and see what's going on. I think at this point, we are ready to open it up to some questions. And this last slide I'll throw up is just my contact information. Feel free to get a hold of me if you have any questions. And there's a list of all of the articles that I've written for EngineYard on various key value stores, Tokio Cabinet among others. And my wrap-up article just got pushed out, I believe, right before we started this webinar. So I'm open for questions now.
All right, that was a great tour of Tokio Cabinet. Thanks, Kirk. We've had a really good audience, and I think all the questions that have been asked so far have been answered by other people in the webcast. There was just one. James was asking if anyone knows if the database is being used. No. Well, yeah, you haven't answered that. Is the database being used in production by any company already?
Oh, Tokio Cabinet? Sure.
Yeah.
Yeah, it's being used in production by a lot of folks. There are a number of EngineYard customers that are using it, and yeah, I think someone mentioned it. I can't remember the name of the Japanese social networking site off the top of my head. It starts with an M. Mixi, that's it. Yeah.
Mixi, yeah.
Yeah, it's huge, and yeah, there's a lot of people using it in production.
Okay, good. And then James also asked, that was the question I thought I was reading, whether you discussed replication and backup.
Yeah, I didn't. There's nothing built into it to support replication. I get distracted here when I watch the chat while I'm trying to talk.
It is distracting, yes.
There's nothing built in for replication. As far as I know, and if I've missed something, hopefully somebody will let me know. But as far as I know, there's nothing out there yet that wraps that up for somebody and presents a replicatable Tokio Cabinet database. But I'm sure that is something that's on somebody's radar. It's got to be.
Okay, and did you see Pedro's question about, can you talk about the update logs?
Let's see. I saw crash recovery, what happens to the database if there's a crash.
So you can get that one first.
And normally what happens is that the database is intact. Tokio Cabinet goes through great pains to try and make sure that it's got a consistent, uncorrupted copy of the database on disk at all times. Like I said at the beginning, the one case that I've heard of so far where that failed was in a case where they were using asynchronous puts. And I'm not sure off the top of my head if the Ruby APIs allow you to expose that functionality or not. You can access it through the C API, but I'm not sure if the Ruby ones expose that. But when they were using asynchronous puts with a file system that filled up, they got a corrupted database. And I believe that they had to do some low-level grunt work in order to get that cleaned up.
Okay, and let me see. So, and James wrote, so interesting, so the write and read will be hitting a single database. There won't be a lot of I/O contentions?
Yeah. The write and reads hit a single database, but it's got an interesting structure where it keeps the buckets, the map of where everything's at in memory, and it maps a lot of stuff so that in practice you don't end up with any significant I/O problems as long as you have a sufficient number of buckets to avoid the simple problem with hash collisions. Hey, someone just commented that it provides master-master and master-slave replication. Cool. All right. We haven't seen any real I/O problems as long as the number of buckets is sized appropriately. When that's sized appropriately, you can hammer the snot out of it, and it just comes along with no problems.
Okay. Do you think you could comment now on the update log feature?
Yeah, let me scroll back here.
It was.
Oh, yeah, it just hopped. Okay. Excuse me. The update logs feature is something that I haven't actually used personally very much, so I'm not going to comment on it because I might say something wrong there. So,
Okay. Fair enough.
I'm going to defer that one because I haven't actually had the opportunity to mess with that particular feature very much.
Okay,
it just works for me.
So James is also asking what kind of application would be best suited to use, I think he means Tokyo Tyrant, aside from Facebook-like apps.
A lot of what I would use it for would be things kind of like along the vein of the examples that I have here. Cases where you have a whole bunch of data that may be structured in a semi-structured way, where you have a number of different fields, a number of different pieces of data that you need to keep track of, but where querying the data tends to be fairly simple and straightforward. I would use it for a lot of different web type applications where you just need to present data or do simple manipulations of data. You need to store historical data, that sort of thing. Any of that kind of stuff, I wouldn't think twice about using it instead of using a relational database.
Okay. And Rich has a question. He calls it a generic 20,000-foot question. What's the big benefit over a two-column Oracle table? Is it performance?
Yeah, I think the big benefit is performance, and in a lot of cases, again, it depends upon your data and depends on what you need. There's Oracle. There's a lot of maintenance tasks associated with Oracle. Sure, once you get it set up and configured right, if your user base is relatively stable and things aren't changing, Oracle will just sit there and hum along and run. But this is very easy to just pop down onto your laptop, type a few commands, and boom, you're running a Tokyo Tyrant server, and you can go create tables. And it also has a benefit in that being schema-free. If your use case changes over time, your application changes over time, you can just change your data. You don't have to worry about being locked into particular table definitions and having to migrate your tables and that sort of thing. You just change how you're using your data, and it just works.
Okay. And then, let me see, Randall's asking, does Tokyo Tyrant have transactions? Can I do atomic updates that change multiple values in MVCC or locking?
Yeah. Tokyo Tyrant, it's, what am I trying to say here? I got myself distracted watching the conversation again. All right. Tokyo Tyrant, each of the updates in it is itself atomic, so that if two people are trying to, like you're going through, you're going through Tokyo Tyrant, you have two different connections that are trying to update the same record. One's going to update and then the next one's going to update. And if a read happens in between, then it'll stay consistent. And I am not sure if you can update multiple things in a row with a transaction or not. Again, that's one of those things that I've just never had a use case to care about it. So I don't know off the top of my head.
Okay. All right. And Conrad's asking, do you know of any projects for integrating Tokio into Rails that's a replacement for Active Record?
Well, Active Record is just a object relational mapper, and so it is not quite, it's not comparable to Tokio Cabinet. I don't know if Active Record has any sort of interface to Tokio Cabinet. I would bet not. But you can always use something like, well, any one of these bindings or Moneta, which I just realized as I was talking, I never put a link in for that in my slides. I meant to. Or I believe... Can you
type it in the, do you have the URL? You could type it in the chat room.
Yeah, a second. I actually have it up on my web browser. I will pull it up while we're talking. But I believe that Data Mapper, if I'm remembering correctly, Data Mapper, which is another Ruby ORM, has a driver for Tokio Cabinet. Yeah, here's the URL. Let me cut and paste it.
Okay,
that's the URL for Moneta. And Moneta is just a unified wrapper over a bunch of different key value stores to provide the same API.
Okay, good. Good. Okay, any other questions, folks? It's good discussion going on here. So, Kirk, all of your articles about this can be found on your blog on the Engine Yard site.
Yeah. Yeah.
So rather than memorize all these URLs or type them out, we can just go to Engine Yard blog and find you?
Yeah, go to Engine Yard blog and find me. Or the last one is up there right now, and it should have links to the various other ones. So you can get an overview of a whole bunch of different key value stores.
Okay. And there was some talk earlier about the APIs and I think you mentioned Ruby, Perl, what else?
The languages that have interfaces to it are Ruby, Perl, Lua, and Java.
Okay. All right. So there are quite a few of them. You can take your choice. All right. Any other questions, folks? We're just about out of time. Randall, are you going to expand on your comment about being a Tommy? Okay, well, I think that's about it. So, Kirk, thank you. This is an excellent, excellent talk.
I see one quick little question there. Someone asked how it compares to Cassandra.
Oh.
Cassandra, I covered Cassandra in one of my articles, and Cassandra struck me as the weirdest key value store I had run across. Its model for how it stores data kind of bends your brain a little bit, and it is pretty neat once you let your brain get bent. But the nice thing about Tokio Cabinet and some of the other key value stores that are similar to it is that it's straightforward and it works the way you expect it to. And as for how you choose what key value store, I think you skim information about various ones, and if one of them catches your eye with how the API works or some feature set, go try it, run some benchmarks, and see if it works for your application. If it doesn't work, benchmarks are easy to run. And if it doesn't work, pick another one and try it again.
Okay. All right. Do you see that comment about
I do not know him. I've never spoken to him, actually. But, yeah, Tokio Cabinet probably could use a IRC room on Freenode.
So the question for those who'll listen to the recording and won't see the question was, do you know Mikio, the creator of this, right?
Yeah, Mikio is the creator of Tokyo Cabinet.
Tokyo Cabinet needs an official IRC room, definitely. Okay, well, that's about it. Kirk, I can't thank you enough. Thank you so much for doing this. And everyone, thank you for participating in the conversation today. It was really quite good.
Thank you, everybody, for tuning in and listening to me. I appreciate it.
Yeah, so if you want to keep a copy of the chat room conversation, you'll need to copy it and paste it into a text file. So just take a moment and do that now. If you don't get a chance to do that and you would like to have a copy of it, just email me at webcast@o'Reilly.com and I'll send it to you. And I will also send everyone an email in just a couple of days to give you the links to the recording. And as Kirk said, the slides will be available on the Engine Yard site in just a couple.
Yeah. We'll put up the slides, and we'll put up a tarball of all my little code samples. So if you want to download them and play with them, you may.
Okay, great. Okay, everyone, thank you so much. Hope you'll join us again. Bye.